Hello everyone, welcome back to the Data Science Exam Preparation Series. Today we are on our last question number 9. This is a very interesting question because now we are moving from classical machine learning into neural networks and deep learning. So let's complete this final question with full clarity. Question number 9A part is obtain basic logic gates from neural networks. Summarize this in a table with a number of neurons, activation function and back propagation in neural networks. So basically, first concept is a single perceptron can implement basic logic gates like AND, OR, NOT, XOR and so on. So it takes input, multiplies them with a weight, adds bias and applies activation and records these different logic gates present. So like this a perceptron changes the gate nature, depends on weight and bias. So if we are discussing about AND gate, suppose we have two inputs like x1 and x2. We have weight 1, we have weight 2 equal to be 1 and bias we have minus 1.5. So only when both inputs are 1, so the total become positive. This is the AND gate. If we are discussing about OR gate, like weight equal to 1, weight 2 equal to 1 and bias equal to minus 0.5. And if even one input is 1, output become 1. This is the concept of OR gate. Now next, NOT gate equal to what? How NOT gate implemented? Like input signal, weight -1 and bias 0.5. So the output becomes opposite. This is the concept of NOT gate. Like XOR gate, XOR is not linearly separable. It cannot be turned by a single perceptron. It requires a multi-layer neural network like hidden layers, and you must use base propagation for the end. So table like we I already written on the screen the table. The difference like layer neuron activation function linearly separable and need back propagation or not. So in AND gate, one neuron activation function is sigmoid for this type, linearly separable yes, need back propagation no. So in AND or no they are same, but in XOR minimum two layer MLP is used, whereas sigmoid and ReLU activation function is used. Linearly separable no and need back propagation yes. This is the whole answer for this question. Now next question. In part B we have to compare CNN, RNN, GAN and transfer learning. So CNN stands for convolutional neural network. Convolutional neural network architecture uses convolution and pooling layer. Learns spatial patterns like images, objects, spaces, application image classification, medical imaging, face recognition. This is the main core concept of CNN. Moving ahead with the next concept, RNN, recurrent neural network. Architecture defines feedback, connection and hidden state. Learns from sequential patterns and application here is speech, text or time series. Next, generative adversarial network. Architecture defines generator plus discriminator. Computing learns to generate new data, application, deep fake, image generation, image to image translation. Next is transfer learning. Transfer learning idea is use pre-trained model, fine-tune for new data set. Also benefit here is saves time, less data needed, excellent accuracy. Application used for this classification, object detection and identity task. So the quick comparison is CNN is convolution layer, RNN recurrent layer, GAN generator plus discriminator, transfer learning pre-trained model. So we have written this all thing in the form of table. You can see on the screen. So till this video we completed all our questions from question paper of data science with detailed explanation, algorithm and example. So thank you so much for watching the entire data science playlist. I hope this lecture helps you to clear your concepts and also see you in the next videos for upcoming question papers. And I hope you like my video. Thank you. Keep learning, keep exploring, keep